In example 1, it's got a combination of the ways in which the information is given to you. There's information clearly given in worded sentences. There's information given to you in a table, which we're quite comfortable with because we've been studying our linear functions being represented in a table. Clearly we don't have a graph and we don't have an equation, but we are quite comfortable with the information being given in a table, and we know how to deal with and how to use that information when it's presented in that way. Okay, so Brett is organising a 21st birthday party. The total cost of the party will include $200 for hiring the hall, $120 for music, and $14 per person for catering. The table below shows the total cost in C dollars for different number of guests, N. So the number of guests is going to be represented by the variable N, or the pronumeral N, attending the party. Now, obviously this is a table of values. I guess what we're a bit more used to is having our X variable along the top and then our Y. There's no reason why you can't put that on there until you need to replace those with, obviously, you can work with your equations in X and then eventually replace the X with an N, and you can have your Y until you eventually replace it with the C, knowing that linear is in the form y equals mx plus b. So A says, which variable, N or C? So that tells you what the variables are. They're either N or C in this case. Now, normally, like I said a moment ago, we feel much more comfortable calling them X and Y because we did all this study about linear functions in the form with X and Y. So, and we know that the Y was the dependent, so the dependent goes in the bottom and the X is the independent and it goes across the top. So we're not allowed to give an answer X or Y. In part A, we have to use the variable N or C. So we identify that it wants the dependent variable. So dependent variable is here, and we can see that the appropriate variable or pronumeral. Now, these are things for you to note. If it needs to go in key points for this exercise, then you make sure you put that a variable is a pronumeral. Write that in your key points if you think you'll forget that or not recognise that word variable in the future. So the dependent variable is C, which represents the cost of the party. It's not necessary to actually write that. B, find the gradient of the linear relationship between N and C. Gradient. We've got to highlight gradient. Now, what connections are you making? Well, for this particular question, you're making the connection between gradient and a table of values. What have we previously done where we've studied gradient and a table of values? Hopefully you will remember that gradient was, we used the letter or the pronumeral M, and when we're giving information in a table, the gradient is found by the change in Y over change in X. Now, you'll clearly be having trouble at this stage doing that if you didn't learn this back in the previous exercise. I can't emphasize enough that what you learn in one exercise then has to stay with you, certainly for the rest of the chapter and certainly until October 2019. So it's not just learn it to do this one exercise and then forget about it. It has to be locked in to your long-term memory. Now, how you lock it in will be different to how the person next to you locks it in. Some people need to write it many times. Some people need to say things. Some people need to see it written, put on a piece of paper, up on the wall, and look at it every day. And then it becomes imprinted in their memory. There are just some examples of how you learn something off by heart. Okay, so we're looking for the change in the y, which is actually the change in the dependent variable, and in this case it's the change in c. The change from 1,440 to 1,720 is, well, I'm just going to write the sum here and then go to my calculator. That's going to be the change. It's more than one thing and it's going to be in a fraction, so I put it in a bracket. The change in the x values from 80 up to 100 is 100 take away 80. That is the change. Obviously I paused the video, and you can too at any time. You can rewind a little bit and pause it and go to your calculator and make sure that you're getting this answer 14. So we've got this number 14. What does it actually represent? Sorry about that. There's an aeroplane going by. It's gone now. What does this 14 represent? It represents the change in the y, which is the change in the cost, and it's a plus 14. So it's the increase in cost per guest, per one guest. So it's the cost per person. $14 is the cost per person. Clearly, it did mention other costs, and we expected to get a 14 anyway, because up here in the question, they gave us the information that the cost would be $14 per person. Now in part C, it says find the vertical intercept. What does that mean? What's this vertical intercept of this linear relationship? Tells you over here, and this is not going to happen every time. Vertical intercept is the more general name for the y-intercept, because linear functions can use variables other than x and y. So it's the vertical intercept. Now, if we had a graph, it may be very easy to read off where the line touches the vertical or the y-axis. We don't have a graph. Another way for us to get the vertical intercept is to realise that the vertical intercept is really that b is equal to b in y equals mx plus b. Well, we have that y is equal to, we've just worked out the gradient, it's 14x plus b. We know that we want to find this b. Back in the equations, the first equations chapter, if you want to find a pronumeral, you must have numbers everywhere else. So I'm wanting an x and a y pair to sit in here. When x is a number, what is the y number? I'm going to substitute those in there and create an equation just in b. But where am I going to get my x and y values from? Well, I'm going to get them from the table. Here's a pair, and what that pair says is when x is 80, y is 1440. So I'm going to use that information and create an equation I can solve. So 1440 is 14 times 80 plus the b. Because remember, the question said find the vertical intercept. So I'll just pause the video and go to my calculator. I suggest you do the same, because really all we're doing here is solving an equation, and I'll need my calculator to work out the... Okay, I've done that and I've got 320. Now, what is the vertical intercept? What is the meaning of the vertical intercept? It is the initial value, the initial cost in this case. Why was there an initial cost before anyone came to the party? Well, if we go back and read the information, it said the cost of the party included $200 for hiring the hall and $120 for music. If you think about 200 at 120, Brett already had to outlay 320 when you add those two together to get the party going, to be able to put the party on. So that's what our vertical intercept actually is, and it's what we would have expected, because we can see from the information given that the initial cost of the party was $320. D wants us to write the linear function for C in terms of n. So no more x and y, no more x and y. We can start with x and y and put our values in, and remember from back here we had that y is 14x plus, and back there we didn't have b, but now we've found b, so it's 320. That would be a linear function. However, the question asks for the function to be in terms of c and n. C is in the place of our dependent variable, or y, and there's an n variable instead of x, because that represents the number of guests. This is a nice choice of variable, capital C, because it represents the cost. Plus 320. If the function was, and then up to E, if the function was graphed, which variable would be shown on the horizontal? The variable on the horizontal would be the n. F is, what does the vertical intercept of this function represent? Vertical intercept, well, I already answered that for you back here. It is the initial cost. And find the cost of the party if there were 95 guests. I'll just pause the video and do that calculation. And as you can see there, I've just substituted 95 into our formula, done the calculation and got 1,650. Now, I'm going to leave the second example and do that in class with you after asking you some things like, what did you put in your summary for this exercise? What key points did you note? So when you're able to answer those questions, I'll do the example too. But also before you get to class, you might be able to do at least question 1 or question 3, then leave these more difficult ones for in class. So do these for homework, and then we'll address those more difficult.